So a football was kicked. Its path can be modeled by the relation h equal -0.1 d minus 8.7 squared plus 7.6, where h is the football's height above the ground and d is the distance, horizontal distance from where the football was kicked, both in meters. What is the vertex of the parabola? That's right. So the vertex is h and k. So in this case, it's 8.7 and 7.6. Okay? What is the football's initial height? So how can I find the initial height of something, or the initial information, or initial value? So think about it this way. You have the football, right? And then what you're looking at is when the football and the height of the football goes up and it goes farther away from the kicker's leg. Okay? Initially, the football height is right here, right? How far was the football's height from the kicker's leg? It's on the kicker's leg, right? So what's the distance between the football and the kicker's leg? Zero. It's zero. The actual distance from the kicker's leg to the football is on his leg. So that distance is zero. There's no distance. So anytime we look at initial value, we're looking at the x, whatever the x is. In this case, the x is d, right? Because I have distance versus height. Instead of x, I have a d, and instead of y, I have h. Okay? So what is the football's initial height? So I'm looking at a distance of 0. Okay? Because that football is on the kicker's leg. So there's no distance between the kicker's leg and the football, right? So I'm looking, anytime you're looking for initial means you're independent, which is your x letter, so the letter that is representing x is equal to 0. Okay? So in this case, instead of x, I have a d. That means I'm looking at when d equals to 0. Okay? So I'm looking at the height of the football when the distance is 0. Do we understand this? Okay, so let's do the math here. So BEDMAS says I have to do the brackets first, right? So 0 minus 8.7, that's negative 8.7 squared plus 7.6. Then BEDMAS says I have to do, after brackets, I do exponents. Yes? So I have to do negative 8.7 squared. So that gives me 75.69. Then after I do the exponent, I have to do the multiplication. So I have to multiply by negative 0.1. So that's negative 7.569 plus 7.6. And then to find the final answer, I add these two. And I know that the height of the football is 0.031 meter. So remember that this is the football, right? The football is right here. How far is it from the ground if you actually look right here, right? It's on his leg, and his leg is literally on the ground, right? So it's basically how thick is his leg, right? So if I do this, right, that's That's how high the football is above the ground. 0.031 meter, right? Makes sense. It's not that high off the ground. So the initial height of the football is 0.031 meter. Okay. Now, I know 2 points, yes? I know my vertex, and I know the initial height. Now they're asking me to graph. To graph, well, 2 points is not enough. I need at least 3 to be able to graph. So here's what we're going to do. So first of all, we're going to put the axes a little bit, and I'm going to move them. So this is where your height is, and this is where the distance is. Now, and they're both in meters. Now, what do I know? What points do I know? What points do I know? I know the vertex, right? I know the vertex is at 8.77.6. So if I go 8.7, let's say this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. And then the maximum height is 7.6, so I can go 1, 2, 3, 4, 5, 6, 7, 8. Okay, so to locate the vertex is at 8.77.6. 8.7, so if this is 8, and this is 9, 8.7 is almost up here, and then 7.6 is almost right there. Okay, so this is where my vertex looks like, where it is. What other point do I know on that graph? What did I just find here? The H and K I already located, which is this, right? Which is 8.7, 7.6. But what did I just find right here? What did I just find? I just found the initial height. What's the D for the initial height? 0. And what did we find the H to be? 0.031, right? So I found that another point, which is 0 and 0.031. Okay, so 0.031 is almost right here okay? Not even. It's closer to the 0, okay? So far I have these 2 points. Now, this is not a full quadratic, right? If I want to graph, I have to graph the other side of it, yeah? What do we know about the vertex? We know that the vertex is in the middle of your graph, yeah? We know that the vertex runs through the axis of symmetry. So that means anywhere from here to any point, right, is going to be equal to, if I go from the middle to the left or to the middle to the right, it's going to be the same thing because this is where your axis of symmetry is, okay? So if I know that this point here is 0.031 and it's 8.7 away from the vertex, right? If I go 8.7 meter to the right, so what's 8.7 plus 8.7? So that's 17.4. If I go to 17.4, my height is going to be 0.031. If I go to 17.4, my height is going to be 0.031, and then I can graph the other half of the parabola. Okay? So here's what I did. Eyes on the board, please. So from the axis of symmetry, from the vertex to my initial value right here, I have 8.7. Yes? I have 8.7 from the axis of symmetry to that initial value. Okay? I can go exactly the same amount from here to my end, right, at 0.031 because of that symmetry. So if I know this point, I can find this point by taking the same distance, okay, and plotting it because of that symmetry. Does that make sense? So to find that value, the D value, I just basically took the 8.7 and I added another 8.7 because I know that this distance right here is 8.7, right? From 0 to 8.7, that's 8.7. If I add another 8.7 to it, that takes me to the 17.4. And then my height is the same as that height, which is 0.031. Okay? Now it's asking, what does the vertex represent in terms of the football path? So it says that the maximum height of the football was reached at a horizontal distance of 8.7 meter and a height of 7.6